case, I'm just going to open up the order form. In here, there's a new option added in the gingiva section. It does not matter what tooth you select if you're just doing the single object copy mill. And you just choose the copy denture option. If you have just this, it should add all the units that you're working on. And it really doesn't matter if that is accurate or not, because it's just going to copy whatever you scan and produce one STL of whatever you scan. This option is good for copying a denture, but you still want to do a try-on. It's also good for copying pretty much anything else that you wanted to get a 3D STL of, be it teeth related or not. This option is not good for copying a already waxed up bridge, because the scanner is still going to have a hard time capturing the internal areas for both implants and most crown cracks, unless maybe for certain molars since they have larger openings. But still, in general, we are only recommending this for dentures primarily, or anything that technically does not have an internal area. So in this case, I am just going to be copying the upper arch, even though I have both dentures, but I am going to still scan in the opposing denture as a model, since I want to be able to know where my bite needs to be if I make changes. So I'll add that in and start scanning. Okay, so you can see it opens up the scanning program, and our first step for the upper arch is scanning the top side of the denture, then the underside, and then we get to line up those two scans together. So as you can see here, it's just expecting you to put the denture or whatever you have on the putty. You don't have to use anything special or buy a special scanning plate for it. So as long as it's all on the plate, just throw that in and get going. In this case, I'm using an E1, so it's not the fastest one, but it still is going to capture all the way around in a higher resolution, so it won't ask for a preview scan. In general, you probably are going to have to use a good amount of scanning spray or powder as needed, since most of the dentures that we'd be using this for are fairly reflective or transparent materials. In this case, this demo denture shape is just made out of a wax material, so I have to use a lot of zirconia dust. Okay, so now that the scan's finished, I'll take a look around, see if there's anything that I need to clean up. If needed, I'll do that using one of the adaptive scanning tools, either fast or detailed. Fast is usually enough, and I don't need nearly that much circle size. Just highlight that bit, maybe a little bit there too. And that should be fine. Next. And we'll just add to the scans that were already there. Not exactly where I was expecting it to add to. But okay. but I'm going to say I'm happy enough with this. You'll continue next, and you should always trim these scans, because if I try and combine the upper and the lower and it has all this extra stuff like the putty and the plate, it's going to be a wild mess if it even works. So I'm just going to use one of our trimming tools. I like to use line mode for the vast majority. You'll just left click or draw your way around what you want to keep. I don't need to worry about going all the way down to the bottom because the other side scan is still going to capture the buckle sides of this denture anyways. So they'll all be overlapping and filled in. Okay. So double check there aren't any floating bits, that it's kept everything you want. And then next, I'll just flip over my denture model or denture copy to the other side. And again, nothing special about positioning. So again, this workflow is only for copying things without a small internal area. If you do have objects with small internal areas, you should set up those items as wax up or wax up abutment in the order form and bridge them together so it takes you through the wax up bridge workflow. Okay, again, looking around for any rough areas. I probably should get the edges of this a little bit better, so I am going to use adaptive scanning again, just highlighting the problem areas. And next, and we'll just fill that in as needed. Okay, give it a second to let it process everything together. If we were scanning anything that we did not plan on modifying in any way, then it's perfectly fine to do this without an opposing. But for this case, I am going to capture that in. So I'll continue next and just trim away what I don't need. Again, I know the top side of this is all captured on the other scan that I just did, so I don't need to worry about cutting away these teeth. Back here, I know my trimming line on the other side was on this side of this edge, so I just need to make sure I'm including as much as possible. Okay. Just look around again, double check that we have everything. Looks good. Continue next, and from what I've seen, it almost always gets the alignment on its own. If not, we still have a manual alignment where we can use points, just like normal. And like usual, we're looking for the speckled pattern to tell us everything's lined up. I'll continue next. And the remaining steps are pretty similar to what we're used to. For this, I'm just going to load in my opposing model, in this case, an opposing denture. And then I'll scan them together for a byte, just like normal. I'll highlight what I want for the detail scan for my opposing, mainly just the occlusion, and then continue next. This one I haven't used very much powder on it, so it's not going to capture quite as well. But that's fine, since I'm just using it as a reference for the occlusion against the opposing. I'm going to say I'm fine with whatever result it gives us, so while that's loading, I'll get our byte set up. Just like normal, you just put the object or denture you're trying to copy onto your opposing and just hold them together with rubber bands or whatever else you have on hand. Just like usual, it doesn't really matter what the rubber band is covering, as long as you know everything's together in occlusion and we're going to capture enough of both arches. Just check and see. Yep, that should be good enough. Okay, looks good. I'll check and see if it can line it up on its own. If not, we'll just line up with the dots like usual. Yep, looks like it got it. I'll continue next, and then I can jump straight into design. Because I chose the copy denture without artificial teeth, the design workflow is pretty quick and straightforward. The first step it's going to pop us off at is the occlusal alignment like usual. As far as I know, it should let you pull up the virtual articulator, though I don't know how it'll actually react since the entire object is our design. So that's all this occlusal plane would really affect. We'll continue past this to the sculpt upper jaw, and this is primarily the only thing that we're going to be doing. during this step. So we have our entire object that is our design, our entire denture arch. We have our usual sculpt toolkit for modifying scans, in that we have the wax knife, remove artifacts, and tooth extraction. But we also have some additional tools brought in for attachment, morphing, and plane cut if needed. So we have a little bit more features for modifying this. So for example, this training denture I scanned in has this little attachment here that helped me line up for the bite scan against the opposing training denture. And I don't really want that here if I'm trying to copy and produce this as a real denture. So to get rid of it, I could use the smooth tool if I'm careful, or I could use the attachments to delete it. I'm going to use parametric cylinder hole with my view direction. Just click to place this cylinder. Make sure it's wide enough and tall enough. And that'll get rid of the majority of that shape, since right now that cylinder is set as a hole, so it just deletes everything it intersects with. Then I can use the wax knife to smooth it out the rest of the way. I can take this time to smooth out any other imperfections from the model that I'm copying, or I can clean up any defects from how this was scanned in. Maybe a weaker strength to clean up this rougher area without reducing it too much. I can use the tweezer if there's a change to the anatomy I wanted to make. Anything that you need. Once you're happy with any of your changes, you'll continue next. It still gives you your sculpt lower jaw for the opposing scan, but there's nothing we really need to do there. So I'll continue next, and then it'll just save that denture shape as an STL. So again, this workflow is extremely open-ended because as far as I've seen, it does not really care what you scan in as long as you're producing a closed shape. So you can use this to copy a huge variety of other indications other than just dentures. I'm going to close out real quick and go through the other workflow if I don't run into a manufacturing error because of the process I chose. And I'm just going to copy this case. So instead of doing just the simple copy mill where it's just producing one STL file, I'm going to do a copy denture for a final denture, one that has separate objects for the teeth and the denture base. For the scanning side of things, that's all done the same, so I don't have to rescan this case. But what I am going to do is add all of the teeth. So I'm going to select all of the teeth involved in this denture, set it up under anatomy as artificial tooth, and gingiva will still use the copy denture option, the same as usual. I'll hit OK to save. It may warn me about rescanning, but I'm going to hit no. And then just jump into design. And I won't be reusing the design from before. So the beginning steps of this workflow are much the same. So I've got my occlusal alignment. I can sculpt and modify things if I want, which again, I want to get rid of this little post here. So again, there's a couple different ways of doing this. I'm going to use smooth here this time. And eventually it'll make its way down. Here we go. Good enough for me. Next. I don't need to modify my opposing. Next. And then we get into the added steps. So we need to identify what teeth is what, where our separation is going to be, and what actual shape we want to produce for the teeth. So starting off, it just wants me to label all of them in order. Just keeping that in mind, right now it's using my FDI notation instead of the 1 through 32. So quadrant 1, number 7, 6, 5, 4, 3, 2, 1. Quadrant 2, number 1, 2, 3, 4, 5, 5, 6, 7. And your points don't have to be exact, they just want it to be roughly around the middle or at the incisal edge of any of your arches. So I'll continue next. The software should attempt to automatically identify where the edges of the teeth, where they meet the kind of tissue side. So you can see it's taking a bit to load, but it's coming up with lines automatically for this. This is treated similar to the sectioning step that we do in most unsection model cases or digital impressions, but the layout is a little bit different. So by default, all of these group teeth options are off, meaning that I've got a separate line for each tooth here, and it's going to produce a separate STL for each one that I would have to mill or print out. I can group the teeth in various default orientations, so I can have 3 blocks, 2 posterior and 1 anterior. I could have it all in just one bridge for the teeth. I could separate the anteriors out, or I could just split it down the middle. I'm going to do the 3 since that seems to be the most popular one. It'll take a second to load, but it's going to combine all of these so that I have one line for each group. If you want to modify any of these, you have to go into this editing mode, draw manually, and then just make sure that it's highlighting in red the arch that you want to change. So I can just draw and change what's included or excluded from this bridge. Clean things up if needed, but from what I've seen, as long as it's scanned well enough and it's a fairly normal shape, the software does a pretty good job of detecting these edges. Additionally, from what I've seen, I have not run into any errors so far related to the overlap, though I haven't really tried to push that limit too far. So I'll just click on the next arch, then I can modify it as needed, clean up any weirder lines that it's got. Okay, next, last one, I'll just double check this. Doesn't look too off, should be good enough for me. So once they're happy with where all of these borders have wound up, they can continue next, and we have our final series of steps. This next group of steps should be pretty familiar if you've done teeth blocks during regular denture design, because the workflow is pretty much the same. It's going to start off by showing us how it separated these teeth and made the bridges, and give us a chance to sculpt those bridges, included the interproximals and underside. So for this, I'm going to turn my tissue slightly transparent so I can see what it's actually made. It's a little rough in the way it kind of cuts away and shows you the underside. Just keep in mind that this underside is going to completely change in a second. What I want to take care of right now is I want to use primarily the minus tool to cut back the interproximal areas and to hide whatever is on the underside below the tissue. As long as it's below the tissue, I don't really care too much what it looks like because it's going to be reshaped as long as it's underneath. I'm also going to reduce the interproximal areas even if it's not underneath, because it's going to allow the connectors to be a little bit thinner, so there'll be less of a gap there when it cuts away to create sockets. So just reducing things as needed. So normally I go around double checking that the shape of this border winds up exactly how I want the final result to look, but I'm going to say I'm mostly happy with this. Once we're finished sculpting the bridge shapes and I double check that there's nothing else exposed that I don't want to be, we'll continue next, and it lets me sculpt the denture base. At this point, usually people will spend a little bit more time with a combination of the tweezer and the plus sign tool to cover up and fill in those interproximal areas. So I can use a smaller tweezer tool to fill that in a little bit more. Hide some of that connection that won't look supernatural. Or I guess that won't look super space natural. It will look unnatural. So they just adjust that as needed until they're happy. I'm going to say this is good enough. But basically, we just want to have the edge between this defined exactly how we want it. Because otherwise it will completely error out or cut some weird shapes. Because as soon as we continue to the next step, it's going to completely reshape our bridges based on where that intersection between the gingiva and the teeth is happening. So as I continue the coupling mechanism, it gives me a couple settings here that I can change. So I can adjust what angle this is seating from. Because I can see some of the blue here, it's trying to show me what angle is going to be exposed following that insertion path. Usually you want to focus on the teeth that you're looking at, have that mostly pointing straight up at you, which you can set with view, and then maybe a little bit buckle from where it's at, so that if there are gaps around the teeth to get it to fit, the gaps wind up on the lingual side. So I can preview to see what this looks like. So now we can see, if I turn this off, it's created much thinner connectors, it's much more shallow, it's not a big wide block. It's just going 2 millimeters below the surface of the tissue that we designed. And the coupling angle, this tapering effect that it's got, is at 10 degrees. Generally, from what I've heard, you don't actually want much deeper than this, especially if you're producing the teeth in the same type of material as the denture, because they seem to bond almost perfectly together when they're the same material, so you don't need to have it super deep. So, same thing as I continue around. Next, for anteriors, the default angle it's got is pretty good. It's mostly pointing towards a top view, except more anterior or buccally to hide the openings that would wind up on the back. I'll preview to see what that looks like. And again, it just reduces everything that was on the underside to make it a little bit more simpler to produce and seat into our denture. Same thing next. I'll just find a top view, make that towards me, and it already is a little bit buccal, so I'm okay with this angle. Preview. Looks a lot cleaner looking. I'll continue to our last step, pre-manufacturing, which functions pretty much the exact same as a regular denture. This is the step where you can just define the spacer between the teeth in the tissue with how it creates the sockets. So my glue spacer can change depending on whatever my preference is. Drill compensation is only required if I'm milling this out. If I'm printing, I don't need it. And then I can just click next to have that apply and save. So now that that's finished, I can take a look. You may notice some of the gaps between the teeth and the tissue are wider than you expect, and that usually has to do with how that insertion path for this bridge would intersect. For example, if the connector here were wider on the bottom, I'd have an extra gap here because it has to be a wider opening in order for that to draw in and out of that socket. But because I used the minus tool to reduce the interproximals a bit, it became a little bit easier to hide that or minimize the chance of that, along with having our insertion path more buckly than occlusally. If I use the cross-section tool, I'll be able to see exactly how the socket was made, that it's matching that spacer that I set of, I think, 0.05. Yeah. And it'll just produce 4 STLs in this case. So 1 for each bridge, and then the denture base with the sockets. Another thing to note for this workflow is, while it is kind of specialized towards dentures if you include that artificial tooth, technically you can use this to separate an object you scanned in into multiple pieces defined by wherever you drew this border between them. So it could be used for non-dental purposes or other purposes with multiple pieces, but it's a little bit more limited because of the extra steps where we're defining all of those teeth and angles. So I'm going to close out and it'll save. It'll probably run into a similar error to I got in a second ago just because of my license. But then it should be ready to go. Both of these features seem to only require the denture module. So as long as they have the denture module, they should be all set. Doesn't seem like there's extra licenses involved with this. If they are on a demo, as far as I've seen for the single arches, I believe it does take a save for each arch. So each object you're producing might take up a STL.